Great, advanced students. Let's go ahead and knock these out. I've got all the odd ones tonight by the looks of it. We see here it says describe a sequence of transformations that maps triangle QRS, that's this one over here, onto TUV, which is this one over here. So first thing I have to pay close attention to is my units. I see this is 4, so half of 4 is 2. Since I don't have 4 lines here, I can assume this is 2. And that would mean that every single one of these halves, right? Every one of these is 2, so half of them will be 1. So when I talk about a translation to the left, we are going to the left this way, right? Translation to the left, and we're going, let's see, if every one of these halves is 1, then this from here to here would be 1, then 2, and then 3 before it reaches this point here. So 3 units to the left. And let's see, how many units down? Well, every one of these, again, is 2. So that's 1, 2, 3, and that would be 4. 4 units down. And then followed by a blank across the blank. I'm going to go with a reflection, because by then, I'm going to draw the new triangle that we moved here. The new triangle that we moved would look a little bit like this. Let's see, this was 1.5, so 1.5 would be about right here, and then down to here, and then over here. So we got our new triangle that looks, wait a minute, that's a little bit off, I'm sorry. Because I forgot that this is 2.5 high. So that's actually going to put this at, let's see, 1, not here, but actually here at 2.5 high, and then coming down, and then coming over. All right. Oh, wait a minute. Oh, I stand corrected one more time. This is where you have to pay very good attention to your lines. This doesn't go straight down, it goes a half over. Wow, this is a lot more complex than I thought. So this new line will be from here to here, 1/2 over, okay? And then it would be coming over here. The only reason I could really tell that is because the triangle I was making didn't look exactly like this triangle, right? And now I know that I have to reflect it across the y-axis, right? So followed by a reflection. Okay, a reflection. Across the y-axis. All right, let's see. Now, that was number 7, so I'm going to number 8. No, sorry, number 9. Number 9. Describe the sequence of transformation that maps quadrilateral ABCD, and that's this one here, the pre-image, to HIJK. So we're taking this one and we're transforming it to this one. And what would I need to do here? Well, I see this one is 1, 2, 3 away, right? So A is at 3 and 3 and 1, right? So this A is at 3 and 1. Okay, so I have to figure out where would A be over here. Well, I can see that this is it's still up and down here, but this one's connected, isn't it, to my x-axis where this was one away. I could say I'm going to come down 1, but that wouldn't be totally accurate because I'm 2 away here, right? Let's see. So, I mean, there's a number of ways to say this. I could say that I transcribed this image, and I'm only looking at A to equal H, okay? Because this started A, I'm thinking A has to equal H, okay? And B has to equal I, okay? So B has to equal I over here, which means if A is over here and I is over here, that means this got flipped, didn't it? Right? It got flipped this way by the looks of it. Or we could say it got flipped this way, right? And if we did, A would be here and B would be here. And then, let's see, I could say it went down. So if I flipped it here, I could say it went down 1, and then I would have to go over to the left. So that would be one way of showing this, I guess. I'm thinking that's the route. So if I wanted to, I could say that I was going, let's see, I could actually say, yeah, I could say I'm going 1 down, right? Let's see if they're wanting me to type this out. I could say I'm going 1 down. Let's see. This is a transitioning, or translation, sorry. Translation of 1 unit down, right? And then followed by, let's see, I could also say that I'm going to take it 6 units. Let's see if I bring it down. I'm going to bring it 1, 2, 3, 4, 5, 6 units, and then flip it, or I can flip it and bring it 6 units. So I could say translating it 1 unit down, and then I could say reflecting it across the x-axis, and then translating it 6 units to the left. All right, that's one way of doing it. Another way could be saying that we could take it 6 units to the left, right? And 1 unit down, then reflecting it, right? So we could put translating it 6 units to the left and 1 down, and then reflecting it across the x-axis. Really, it's all going to be the same type of things, right? We have to bring it 1 down each time, right? We have to bring it 6 units to the left, units to the left, sorry about that. And then reflecting across the x-axis. So whether we do it here or here, okay, it really isn't, it's inconsequential. All the same steps are going to be there. So look for this in your answers. I'm going to put it highlighted for you. So the first thing is a translation of 1 unit down. Ooh, that's ugly. Let's fix that. Translation of 1 unit down. And then reflecting it across the x-axis. And then translating it 6 units to the left. Ooh, another misspelling here. Sorry about that. Okay, and let's get back to our blue highlighter here. All right, and as you can see in every one of these, translating it 6 units to the left. So however they write it, as long as these are the sequences that they show included in it. Reflecting across the x-axis and 1 down. Okay, so as long as they have those 3 steps in there, they're good. All right. Let's go to the next one. Number 9. So I guess the next one, number 11. A student says he was rearranging furniture at home and he used a glide reflection to move the table with legs. Okay, a glide reflection to move the table with legs from one side of the room to the other. Will a glide reflection result in a functional table? Well, it's rearranging furniture at home. We use a glide reflection to move a table with 4 legs from one side of the room to the other. Will a glide reflection result in a functioning table? Let's see here. And yes, I'm going to be a little lazy here because I don't feel like typing all that out. I grab the answer and put it over here so you guys can go ahead and make a copy. The answer, of course, is no. Remember, when you're reflecting, you would have to turn the table upside down, right? So that's not going to work at all. You cannot do a glide reflection of the table because that requires a reflection, and that would flip the table upside down, right? And we're reflecting something, and we're just talking about a table here. I'm going to try my best to make a 3-dimensional table here, okay? When I move it, when I reflect it, that table is going to be over here. Does everyone see that? And that's not going to work. We don't want an upside down table. All right, that's all I had to do. The rest are for you to do. And good luck. I'll see you in class.